All right, in this video, we're going to go over the Module 6 study guide. We went over each one of these questions in class each day, but in case you were absent one day, arrived late, here's all the questions together in one video. So first, we are going to solve the following system of equations by graphing. So we have an equation here, y is equal to 5, 6x minus 2. When I'm graphing this equation, the first thing I need to identify is my y-intercept, which is always the number that's by itself. And yes, the sign is attached to the number. So that is -2. So here on my y-axis, this is where y is equal to 0. So I go down -1, -2, and there is my y-intercept. I identify my slope as 5 over 6. So, because that's the coefficient, the number in front of the x. So from here, I'm going to go up 5, and for a positive slope, I'm going to go to the right 6. Okay, so here's my second point. Now I can draw my line, and now I have to move on and graph my second equation. So I have y is equal to -2/5 x plus 3. My b is equal to 3. So over here, my y-axis, this is 0 for y, 1, 2, 3. Here's my point. Then I have to identify my slope, which my slope here is -2/5. So from here, I'm going to go up 2, and now because it's a negative slope, I'm going to go to the left 5. There's my second point. Now I can draw my line. And now I see that the point where they intersect is right here. Okay, so if I just zoom in, I want you to notice that that point of intersection is actually not at 4, 1 or 4, 1.5. It's not exact. Oops. But that is the point that we need to identify. So here we have to select two true statements about the solution of the system. The y-coordinate of the solution is between y is equal to 4 and y is equal to 6. Well, the y-coordinate of this solution, if it was between 4 and 6, would be all the way up here after 4. And remember, this is 3. So it'd be up here at 4, and the point of intersection would have to be right here. So because that point is not actually, the y value is not between 4 and 6, that is not the correct answer. What is actually the x-coordinate of the solutions are between 4 and 6. Because here my x is 4, here my x is 6, and the point of intersection falls between that range. Now, you'll go ahead and notice that the y value is actually between 1 and 2, and so my other correct answer is the y-coordinate of the solution is between y is equal to 1 and y is equal to 2. They definitely have a solution. They are not parallel lines, and they are definitely not the same line, so they're not infinite either. All right, moving on to question 2 on the study guide. Now we have to solve this system using algebra. So this was Module 6, Lesson 2 notes. And in order to solve this system, we have to try to eliminate one of the variables. And in this particular case, because it's asking for us to solve for the y value, we actually want to eliminate the x value, so we only have to do the work once. Okay, so eliminate the x so we don't have to do more work. So to eliminate the x values, I'm going to multiply this top equation by -3. So I get -6x plus 3y, because -3 times -y gives me a positive 3y. And then -3 times a positive 6 gives me a -18. Then I have to multiply this second equation. So 2 times 3x is a positive 6x. 2 times 2y is a positive 4y. And 2 times 14 is 28. So now that I have the same coefficient for my x values with opposite signs, because one is negative is one is positive, I can add those two equations together. The x becomes 0x, so it goes away. It has been eliminated. And I end up with 7y is equal to 10. So now to solve, I'm going to divide both sides by 7, and I get y is equal to 10 over 7, which is option C. Okay, moving on to our next question, question 3, which is 6.3 notes. Samantha works at an ice cream shop. She sells 2 cones and 3 milkshakes. So the first thing we're going to do is identify our variables. And 2 cones, so cones are going to be my x. 3 milkshakes, milkshakes will be my y. And now I have to write an equation. So 2x plus 3y would be equal to 24 for this first scenario. And then 5x plus 1y, so 5 plus 1, is going to equal 2750 for my second scenario. Okay, so in order to eliminate a variable from the second equation, I'm actually going to multiply this second equation by -3. And the reason why I'm multiplying by -3 is because when I do that, I will have the same coefficient on my y values with different signs. So this equation is going to become -15x minus 3y is equal to -8250. Because 3 times 5, -3 times 5 is -15, -3 times 1 is -3, and -3 times 2750 is -8250. I did not have to change that first equation, so I just left it alone at 2x plus 3y is equal to 24. Now I can add these two equations. I get -13x because a positive 2 and a -15 is going to give me -13x. I have a 0y. They've canceled out, been eliminated. And then I end up with -5850. The last step is to divide both sides by the -13. And I find that cones, ice cream cones, at Samantha's ice cream shop cost $4.50 each. Now I'm going to take that value of the ice cream cone and plug it into this first equation. Okay, so instead of having 2x plus 3y equals 24, I'm going to have 2 times $4.50 plus 3y is equal to 24. 450 times 2 is $9, so 9 plus 3y is equal to 24. Subtract 9 from both sides. 3y is equal to 15. Divide by 3, and y is equal to 5. Now I have the value of my milkshakes. So complete the following sentences. The price of one shake is, well, $5. If Samantha sells 4 cones and 2 milkshakes, then the total cost of the order is what? Well, now we know the cost of the cones, 4 cones, and we know the cost of the milkshakes. So 4 times 450 plus 2 times 5, what does that equal? Well, 18 plus 10 is equal to 28. So the total cost for 4 cones and 2 milkshakes is $28. All right, question number 4. This is what we learned basically in Module 5, but also we did continue to learn this in Module 6, Lesson 4. And this is graphing an inequality. So when we graph inequalities, you have 2 options. You can graph either by intercepts, if you remember how to do that. If you don't, go back and look it up. But today in this video, we're going to rewrite this equation, -2x plus 2y is greater than or equal to 4. We're going to rewrite that equation in slope-intercept form. So if I have -2x plus 2y is greater than or equal to 4, I have to add 2x to both sides in order to move that variable x to the other side of the inequality. Now my goal is to still get that y by itself, so I'm going to divide all terms by 2. When I divide by 2, that simplifies to be y is greater than or equal to x plus 2. So this standard form equation became y is greater than or equal to x plus 2. So here I can identify my b term as 2 because that's right here. My slope is 1 because that's the imaginary number in front of the x. I should have a solid line because this says greater than or equal to, which means a solid line. And the greater than symbol means I should be shaded above. So if I'm looking for a y-intercept of 2, if I plug that in onto each one of these graphs, this is a y-intercept of 2. Here is another y-intercept of 2, and a y-intercept of 2, and another y-intercept of 2. you'll notice just by looking at the y-intercept for that first equation, I have eliminated graph A, B, and D because the y-intercepts are wrong for all of the other lines. Now, in case that doesn't happen on the test situation, we do want to be able to have to rewrite this second equation in slope-intercept form as well. So I'm going to follow the same steps. I have 6x plus 2y is less than 6. I'm going to subtract 6x from both sides. 2y is less than negative 6 plus 6. And then I have to divide all terms by 2. So that becomes y is less than negative 3x plus 3. So in this scenario, I have my y-intercept is equal to 3. So if I had a y-intercept of 3, that would be right here, right here, right here, or right here. And you'll notice, even just by looking at that second y-intercept, yes, there is one possibility here, but none of the other lines actually pass through the y-intercept of 3. It's only true for option C, graph C. So just look at your y-intercepts is what I recommend. All right. So now we're going to look at question 5. And this is the one where we're given solution points or the following points. So what I recommend doing is just plotting these points on a graph or trying to plot them on the graph and seeing if it's true. So if I plot the point 6, 4 on the graph, that does fall in the darkest region. This does fall in the darkest region. This one does not fall in the darkest region, so I can actually eliminate option C and I can eliminate option D just because when I plotted that first point, and because that point was not in the darkest shaded region, I knew that it was not a solution to the system. Now I'm going to look at 5, 2.5. So here that point falls on a solid line that is next to the darkest region. This falls on a dotted line or a dashed line that is next to the darkest region. Whenever a point falls on a dashed line, it is not a possible solution because it has to be on a solid line or well within the dark region. So because that point falls on a dashed line, it makes it not true. Again, we're going to look at this last point, 0, 6. 0, 6 falls on the solid line again. So that confirms that my correct answer is option A, or graph A. All right, moving on to question 6. We have a system of linear inequalities, and we need to graph it and see which one of these 4 graphs matches. So I'm going to look at my y-intercept, and I'm going to look at the type of line that I have. So here, my y-intercept is 1, okay? And I should have a dashed line and be shaded above. So anywhere that I have a dashed line that has a y-intercept of 1, I'm going to consider that as a possibility for an answer. So here is the dashed line and my y-intercept is 1, so that works. Here, if you look, this dashed line has a y-intercept not of 1, but of 2. Okay, now I'm going to look at this one. Well, that works. That dashed line has a y-intercept of 1. This dashed line has a y-intercept of 2, so I can remove those 2 graphs immediately just by looking at the dashed line and the y-intercept. Finally, I need to look for the area that is shaded above the dashed line. So if these are my dashed lines, this side of the line is above the dashed line. So I can eliminate this graph because it's actually shaded below. So this is the best graph for the solution. Now you can go and double check and make sure that the 2 is the y-intercept of the solid line. And here, this should be shaded below the solid line because it says less than, and it is in fact shaded below the less than